We are officially live. In everyone. Everyone is having a good what's today? Wednesday? Yeah. Hopefully everyone's having a good Wednesday. We are indeed back. Yes, we are. Hey Dan, how's it going? We are back indeed. Welcome on in. Let's go ahead as you're joining in. Let's go ahead. Are your topics scheduled or do you do random things every day? So I actually have a list. I usually like to plan about a week out. Um, so if you so on my TikTok account, there's a my most recent TikTok short is my live schedule for this week. Good question. Quotient rule is like the power rule. Yep. So kind of. We're going to be using power rule today, but we're going to be doing it in this context. But yeah, does that mean that sometimes I won't change it up? Yeah, that might happen, but I want to give you all an idea of what to expect on these lives before we get started, right? Especially in this early part. I'm also my students are starting to get settled in for the year. So right now the plan is to do a second live, but I'm trying to figure out when when to do it um and what to do on it. Um yeah. Again, welcome on in to everyone that's joining. Awesome sauce indeed. Yeah, welcome on in everyone. So tonight, as we are doing quotient rule for derivatives. So we're going to start that in a few moments, but before we do, let's go ahead and let's see if we can't get to 1,000 likes before we begin. I know you all got it. Also in the process of uploading all my lives so that way I can post them. Or uploading, yeah. Let's try it again. Downloading them so that way I can post them elsewhere. So that way even if you can't stay for the entire live, that's okay. They're all going to be downloaded and put up on other channels. In fact, after this live, I'm going to be Did this just start? Yep, we just started about 4 minutes ago. We haven't done any math yet. You're going to stay for a couple problems? Okay. Well, like I said, if you can't stay the entire time, that's okay. But all of my lives are going to be downloaded and put up on other platforms, i.e., YT. Um, just want to thank you for teaching us. I really appreciate. You're welcome, Ange. I'm really happy to be on here and showing you all the how great math can be. And I mean, as I said before, and I keep saying it, math is not meant to be the scary monster in the closet. It's meant to be fun and relaxing. And now, I'm sure some of you are thinking, fun and relaxing? What do you mean, fun and relaxing? And that's the thing. Um, Most of us have experiences where we run into teachers that either don't know the material quite that well or really don't care about the topic of mathematics. So they just teach it as if it were as if in fact, I think this is better put as an example. I've literally had teachers that done this. Today, class, we're going to talk about quotient rule, and we're going to work on this because let's be honest, I today is just going to be a really boring day. No, I don't want to teach like that. That is that is that's kind of boring. I've had teachers like that though. Math is pretty cool once you get it. Once you get good at it, it's sometimes still scary though. Absolutely. But I find that a lot of the problems that look scary aren't as scary as they first appear. It's like the Transformers. There's more than meets the eye. So if I have a problem that looks like it takes half a page, and I realize, okay, what what was I gonna say? Oh, what can I? Is there a way to make this easier? And most of the time, there is. Jesus love you. God bless. You're so amazing. Thank you. Thank you so much. God bless you as well. Can you go over our problem, please? Yep. I will in just a moment, Jay. Hey, Dad, how's it going? How is it going? Thank you, Mubarak, for the follow. Okay, so I will go ahead and get started. So, always fun to tune in? Absolutely. You know what? I'll be honest with you all. I have a lot of fun. I have a lot of fun doing these. And yeah, like I said, maybe I drone on a little bit sometimes too much. But you know what? I like to, I like to, talk to you all rather than talk, to a brick wall. Okay. Fair enough. See ya. Thank you, Mubarak, for that. God bless you as well. What's quotient rule? That is a good question, Pluto. I was just about to show you. I assume you're a high school teacher, right? Not college? I used to teach. I'm not a teacher anymore. I just found that teaching in the classroom wasn't right for me, and that's okay. But I actually tutor nowadays. But yes, I did used to teach. So let's go ahead and get started. So let's go ahead and define what the quotient rule actually is. So suppose I have h of x is equal to the quotient of two functions. You have trauma fitness. I'm sorry to hear that. Well, hopefully tonight after this, you'll hopefully 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 watching this. I'm not gonna say hopefully it causes you less trauma because it won't, but hopefully we can heal from that trauma a little bit tonight. So suppose I have the quotient of two functions. Low D high minus high D low square below is how my teacher taught us to remember it. Cool. And it's great that you remember to chant because it really does help with learning the rule. How I learned it was low D high minus high D low all over the square of what's below. So let's go ahead and show that. I'm going to go ahead and as always, I'm going to prove the rule, and then we're going to work on some problems involving the quotient rule. So let's go ahead and get started with a quick proof. So I have limit as h approaches 0. Remember the limit definition of the derivative. It's f of x plus h minus f of x all over h, or the limit as h approaches 0 of that. So here it is. Remember this rule. So my h of x is going to be this. So I have f of x plus h, because remember, whenever I have an x plus h here, that means plug it in everywhere I see an x. So this is going to be over g of x plus h minus f of x over g of x all over h. So with your permission, I'm going to do two steps at once. What I'm going to do is I'm going to have a common denominator in my numerator, but I'm also going to multiply these two fractions by 1 over h. So I'm going to go ahead and do that. So I have limit as h approaches 0 of 1 over h times the following. So I have f of x plus h times g of x minus f of x times g of x plus h all over g of x plus h times g of x. Thank you, Duok, for the follow. So now, what should I do from here? Well, from here, what I could do is I'm going to go ahead and switch my h and this. So I have limit as h approaches 0. I hated this. I missed it 3 times on every final except the final, luckily. Okay. Ah, yes. Every exam except I was going to say that's kind of confusing. X plus h times g of x times f of x plus h times g of x minus f of x times g of x plus h all over h. So now, remember that if I have a multiplication inside a limit, I can split this up into two separate limits. So I have limit as h approaches 0 of 1 over g of x plus h times g of x times the limit as h approaches 0 of f of x plus h times g of x minus f of x times g of x plus h all over h. Yeah, I agree. So if you want, let's call this, instead of h of x, let's call it j of x. But yeah, I agree, Mark. So from here, I'm going to go ahead and I can already do that limit. Why? Because I don't have to worry about division by 0. Well, again, we also have to assume g of x does not equal 0. So, here, if I do this limit, if I plug in 0 for h, I get 1 over g of x times g of x. So this is going to be, so that first limit is going to be 1 over g of x all squared. So now we don't have to worry about this anymore. So now I'm just going to focus on here. So what can I do to go ahead and finish that proof? So from here, oh, I know what I can do. I can go ahead and add and subtract something. So this is going to be times the limit as h approaches 0. I'm going to add and subtract something here to make it 0. Thank you, Moana, for the follow. So what I'm going to do, I have f of x plus h, g of x, minus, and I'm going to subtract an f of x times g of x. And then, what am I going to do? I need to add an f of x, g of x, g of x, minus f of x plus h times g of x. Oh, sorry, that should be the other way. That should be f of x, and this should be x plus h. All over h. You're so confused right now. Okay, where did I lose you? Thank you, it was long for the follow. And thank you, Summer, for sharing. So where did I lose you? So from here, I still have my 1 over g of x all squared. No problem. So what I did was I added an f of x times g of x. However, remember, I can't change its value, so I subtracted f of x, g of x as well. Why would I do that? I would do that because what's going to end up happening is I'm going to end up, or why would I do that? Well, here, I'm not exactly changing the value. All I'm doing is essentially adding 0, but I'm calling it a new name. Yep, this is Calc 1. This is Calc 1. So now, and that helps with what? That's what I was just about to show you. I was just about to get there. No problem. Thank you, Sanella, for the follow. That's exactly where I'm going, Dan. That is exactly where I am going. So I'm going to rearrange this. So I have f of x plus h Yep, I did it in the right order. Times g of x minus f of x times g of x. Can you please do an example of limit to infinity? So, I think I did that a little bit ago, like a few days ago. But like I said, all of my lives are going to be on other platforms, so that way you'll be able to see them there. Oh, why am I doing that? So here, yeah, I do want to do that. Over h plus f of x g of x minus f of x times g of x plus h all over h. Where did the f of x g of x plus f of x g of x, how did you get those variables? So like I said, yeah, it is kind of hard to see. My camera is as high as it can go, and unfortunately I don't have a zoom feature. But I am almost done. So how I get this is like I said, I can add and subtract anything I want as long as I don't change the function, as long as I don't change the value of this fraction. So by adding and subtracting the same thing, I'm essentially adding 0. There's an echo. Okay. For some reason, I think my mic is a little sensitive too. Did you split the fraction into 2? Yeah, I did, right here. Naturally, I should put this in parentheses if I'm only writing one limit. Wait, is this calculus? Yep. Well, what are we working on tonight? We're just working on quotient rule. But what I'm you're not hearing an echo? Okay, awesome. I just wanted to make sure. So, what I'm going to do from here is I'm going to factor out a g of x in this first fraction. So I have limit as h approaches 0 of g of x times f of x plus h minus f of x all over h. And then on this side, I'm gonna just rejoin it. Thank you, May, for the follow, and thank you, Emma East, for the follow. So from here, what I can do is I can add. I'm now going to factor out an f of x, a negative f of x, excuse me. What am I left with? I'm left with negative g of x plus g of x plus h. So I'm going to rewrite that as g of x plus h minus g of x all over h. So remember, I can also treat this as two separate limits. So I have limit h approaches 0. And I can also move that g of x outside. So g of x of f x plus h minus f of x all over h minus f of x times the limit as h approaches 0 of g of x plus h minus g of x all over h. And finally, missing close. Oh, yes, right here. Yeah, it's the difference quotient. And more importantly, it is also the limit definition of a derivative. So this would be g of x times f prime of x minus, right, f of x times g prime of x. But remember, I still have, from over here, 1 over g of x all squared. So I'm going to write this up here so that way we have a little more space. So this is going to be g of x, f prime of x, minus f of x times g prime of x all over g of x all squared. Perfect. Thank you, Cameron, for the follow. Thank you, Mossy, for the follow. Right, Usher, you're exactly right. Yeah, so what I did was, so this is why I added and subtracted f of x of g. So, and let me try it again. So that's why I added and subtracted f of x times g of x. So that way I could get it to a form where I could factor and end up with this. So here, g of x, because it's being more. So remember, so this is the same as if this were, say, a number. So g of x times this, I can take my g of x and move it on out to leave me with this. And this is just that. Likewise, this is just that. But the difference between this and this is that instead of f of x plus h minus f of x, it's g of f of x plus h minus g of x. Thank you, Edgar, for sharing the live. Yep, absolutely you can. As long as it's not being impacted by this limit right here. And since I'm multiplying it, I can move it out. I can move it out like that. Same thing with this negative f of x. I can move it outside. Yes, essentially yes. Thank you, Prince, for the rose. That's right, Ezra. It can. Yeah, definitely. And I promise you, the hardest part of this entire live is done. But now that we've done this, we can add it to our list of derivative rules. So now, let's add it to our list. So if j of x is equal to f of x divided by g of x, then j prime of x is going to equal g of x times f prime of x minus f of x times g prime of x all over g of x all squared. Have I done power rule yet? Yep, I have. I did that. When did I do that? I think I did that, what, Friday? Last Friday? I think so. Yeah. But like I said, all of my lives are going to be downloaded. Hey Azim, how's it going? So now that we've added that rule, let's go ahead and do some exercises with it. Like I said, the hardest part of our entire live is done. Thank you, Jax, for the follow. So let's try our first example. Let's say f of x is equal to the following. Thank you, Pedro, for the follow. So let's start with x minus 1 all over all over 2x plus 6. And I want to know what the derivative of that function is. Thank you, Edgar, for the 20 roses. So, what I'm going to do is I'm going to go ahead and I'm going to name these two functions. What is the name I'm going to give them? For the top, I'm going to give it the name g of x. And for the bottom function, I'm going to name it, what do you want to name it? What letter would you like to assign the bottom function? H of x? Sure. H of x works. So, as well as name them, I need to name their derivative. So the top, I'm going to call x plus 1. And the bottom, I'm going to say is 2x plus 6. Thank you, Wiz, for the follow. What is the derivative of g prime of x? Karen says 1. Scott says 1. Ezra says 1. You're right, it's x minus 1. The function is x minus 1. You're right. The derivative of g prime of x is 0. Yep, that would be right. But what is the derivative of x minus 1? Still 1. Yeah. So remember, power rule. What does power rule say? Power rule says that if I have a function x to the n, what I can do is I can move that exponent out front and subtract 1 from the exponent. Comparing this to your proof, f of x in this problem would have been, yes, you're right. You are absolutely right, Ezra. So anyway, remember that a variable without an exponent is the same as that variable raised to the first power. So if I have x to the first, its derivative would be 1 times x, which is 1, x. And then I have x to the 1 minus 1. 1 minus 1 is 0, and remember, x to the 0 is equal to 1. So therefore, the derivative of that is just 1. You just learned this today? That's cool. That's really cool, user. I know 5 plus 5. That's great, Poppy. So what about the derivative of 2x plus 6? What would that be? Oh, and also the derivative of a constant, if we look at rule 4, derivative of a constant is just 0. I agree, we all do start somewhere. So what is the derivative of h of x? Do you do Calc 2? I do indeed. I do indeed. In fact, where did it go? Here it is. Here's a list of every subject I tutor. And in fact, I think I have USub already on my list of topics. If I don't, I'd be shocked. So here's a list of every topic that's been requested. But in order to do some of these, we have to know the foundational information. Actually, I don't see you, sub. I must not have added. But yeah, I'll add it there. Would you be able to help at all in physics? That's what I'm doing now. I haven't done physics since I was a senior in high school. And that was back in 2011. Could you please do some geometry? Is there a particular topic you want me to, So I usually plan out my lives about a week out, Carter. So on my TikTok, the most recent short that I put out has my schedule for the rest of this week. But yeah. Thank you, Grace, for the follow. Thank you, Carter, for the follow. Just go over angles, the formulas. Oh, and thank you, Kenji, for the follow. Even angle formulas are a bit vague. Is there anything in particular you want me to go over? Velocity, acceleration, what's up, kinematic. Oh, okay. Yeah. What grade is this for? This is Calculus 1. So I've seen students as young as junior take this to as old as college. Yeah. Would h of x h prime be 8? So let me actually zoom in a little bit, and also for some reason my pad doesn't want to cooperate tonight. There we go. That's better. Thank you, Carter, for the rose. Azim says 2. Laurel says 2. Derivative of a constant is 0. That's correct. But I don't have just a constant here. Right, yes. Jack says it's 2. Karen says it's 2. Yeah. So, remember, if I do the derivative of both of these, the derivative of 2x, well, remember, a variable without an exponent is assumed to be 1. So 2 times 1 is 2. X to the 1 minus 1, remember 1 minus 1 is 0. And x to the 0 is equal to 1. So I have 2. And then, if I take the derivative of plus 6, remember that the derivative of constant is 0. So therefore I would have 2 plus 0 or just 2. So now, I have everything I need to take the derivative of the original function. All I'm going to do is I'm going to connect my functions together. So, what would f prime of x be? Well, it would be low d high. So this is going to be 1 times 2x plus 6 minus high d low. This is going to be 2 times x minus 1 all over the square of what's below. Can you do the derivative of 6? 6? Oh, it would be 0. The derivative of any constant is 0. Thank you, Amy, for the follow. So, from here, what I'm going to do is I'm just going to simplify the numerator. So I have 2x plus 6 times 1. Well, anything times 1 is itself. So this would be 2x plus 6 minus 2x, or negative 2 times x gives me a minus 2x. And negative 2 times negative 1 is plus 2. All over the bottom squared. And finally, we can say bye to these 2x's, right? Because 2x minus 2x is 0. And 6 plus 2 gives me 8. My answer is 8 over 2x plus 6 all squared. And that is how that's where I would stop. Cool. Any questions so far? Simple enough. That was just so lovely. I personally would stop here. But that's just me. Why wouldn't I factor out a 4 in the denominator? Why would I? Yes, if you did expand, you could expand the bottom here. So what would that get you? What would that get? That would get 8 over 2x times 2x is 4x squared. Plus 12 is 24. X plus 36. And then from there, you could factor out a 4 in the denominator. And I'd be left with x squared plus 6x plus 9. And it would indeed simplify to 2 over x squared plus 6x plus 9. Yeah, so you could You could simplify. I choose to stop here. But yes, you could continue on. I just, like that, I just choose to stop there. Because if I need to take the derivative again, you've got work tomorrow and could watch all night, that's okay. If you need to go, that is perfectly fine. I'm gonna, like I said, I'm gonna post all my lives that I've done on other platforms, mainly where here, mainly there. So this is where all my lives are going to end up. Thank you for the follow. Do integral sine x squared. So tonight I'm just going to focus on the quotient rule, but I will definitely add that. To the list. All right, so let's go ahead and try another one. Let's try another one. Oops. Oh, I can do it this way. So, let's try 3x squared plus 5x over x minus 6. Actually, let's make it 2x minus 6. Or actually, yeah. I could factor that as x minus 3. Or 2 times x minus 3, but I'm not going to. So again, what I'm going to do is I'm going to go ahead and give the top and the bottom a name. So we'll call the top t of x, and the bottom we'll call b of x. T of x is going to be 3x squared plus 5x, and b of x is going to be 2x minus 6. And now I need to find the derivatives of t of x and b of x. Let's start with t of x. If I were to take the derivative of 3x squared plus 5x, what would I end up getting? Jack says 6x plus 5. Yeah, that's right. Why? Because power rule. And remember the power rule. Power rule says that if I have x raised to any power, I can simply move that power out front and subtract 1 from the exponent. And because I have a 3 in front of here, the only difference between the power rule and what we're seeing is that I just simply take the power and multiply it by the coefficient. So I have 3x squared, so the squared, so 2 times 3 gives me 6. X to the 2 minus 1 is 1, so I leave it as that. And then remember, a variable without an exponent is just x to the first. So it's going to be, so I can rewrite that as x to the first. 1 times 5 gives me 5. X to the 1 minus 1 is 0, so that means that it's just going to be 5. Thank you, Yachty, for the follow. Tomorrow for your trig derivatives, would you just show how sine of x prime is cosine? Yes and no. I think that's going to end up being the plan. I might do a couple where we do product rule and quotient rule for them, but yes, because I have chain rule planned for later on. I'm doing inverse of equations with functions. Okay. So now, what is the derivative of 2x minus 6? That's right, Chris. That's right, math. That's right, user. That's right, never. It's 2. So now I have everything I need to find the derivative of this original function. So I just link my functions together. So I have f prime of x is equal to low d high. So that's going to be 2x minus 6 times 6x plus 5 minus high d low. So it's going to be 2 times 3x squared plus 5x all over 2x minus 6 all squared. Thank you, Jax. Have a good rest of your evening. And yes, thank you. I really do appreciate that. So from here, all I'm going to do is I'm just going to simplify. So I'm going to FOIL over top here. So that's going to be 2x times 6x gives me 12x squared. 2x times 5 is going to be 10x. Minus 36x is going to be negative 26x. Negative 6 plus times 5 is going to be negative 30. When do you think you would get to the Calc 2 material? I'd have to check my schedule. I think I'm going to get there. I'd probably, and again, I'm not sure because I don't have my schedule right in front of me. I'm probably going to get there around, if I had to guess, probably end of September to early October. But again, I don't have my schedule in front of me. It may be sooner, it may be longer, but that's if I had to guess. So from here, I'm gonna distribute in at negative 2 here and here. Negative 2 times 3x squared gives me negative 6x squared. And negative 2 times 5x gives me negative 10x. That's all over. Let's factor that bottom. So I have 2x times 2x is 4x squared. 2 times 6 is going to be negative 24x. And then plus 36. That's by far my weakest subject, so I'll keep checking. Okay. Yeah, that's when I'm, like I said, that's when I'm guessing I'll be starting my Calc 2 material. But like I said, it could be sooner, or it could be longer, but if I had to guess. So now, all I'm going to do is I'm just going to simplify my numerator. 12x squared minus 6x squared gives me negative, negative. Let's try that again. Positive 6x squared. 26x minus 10x is going to be negative 36x. Minus 30 all over 4x squared minus 24x plus 36. And then if we wanted to, we could definitely factor out the top and the bottom. So I could factor out a 6 on top and a 4 on bottom. I'd be left with x squared minus 6x minus 5. And on the bottom, I'd be left with x squared minus 6x plus 6. Here's why. So when I foiled that 2x minus 6, 6x plus 5. So first I have 2x times 6x, so that gives me 12x squared. And then I have 2x times 5, so that's plus 10x. Negative 6 times 6x is negative 36x. And then negative 6 times 5 would be negative 30. 10x minus 36x. Right, yes. But you're right. Down here it's plus 9. You're right. Yeah, no problem, chocolate. No problem at all. Minus 30. But yeah, you're right. That's a 9. But either way, we end up with our answer. Oh, actually, I could factor that out to be a 3 and a 2. And with that, that is it for this question. So really, my steps are this. Identify my top and bottom function. Take the derivative of the top and bottom. Plug it into the quotient rule formula. And then simplify. Yay, math. Yes, indeed, cowgirl. Yes, indeed. Awesome. Yeah, good question, Chocolate. Any other questions? Thank you, Ezra, for the rose. So let's go ahead and do another one. Have I done the product rule? Yep, I did product rule. I want to say Friday. But that one I might give its own video. Not necessarily its own live, just its own video. How about chain rule? Nope, chain rule I'm saving for, I think it's Sunday. Let's see, I'm doing trig derivatives tomorrow. I'm doing implicit differentiation, I think I said on Friday. Saturday or sometime this weekend, we're going to get to chain rule. I just can't remember when. Can you do the integral of 5x e to the negative x, please? I've been stuck on it. Okay. So tonight I'm actually gonna focus on quotient rule, but if you want, feel free to DM me that problem and I'll be able to work with you on it. So let's do a few more, and then we will call it a night. Nope. If he did that, you would still have to find a way to get rid of e to the negative x. I would probably do integration by parts. That's okay, Ezra. Yeah, I would try integration by parts and see how that goes. Because what's going to end up happening is that what would be e to the negative u if we're going to name x if we're going to name x e or x u. Plus the thing with yeah, but again, you'd still have to get rid of the you'd still, so the goal of u sub is when you have a function and its derivative inside the function. Like I did, I would personally try integration by parts, but that's just me. Anyway, let's try another example. And actually, this time I'll make sure I give myself enough room. So I have, let's do x squared plus 3x minus 6 all over the square root of x. So, how would we accomplish this problem? So, let's write down our steps. So, quotient rule steps. So, step 1, identify top and bottom function. Thank you, Fresh, for the follow. So here, what would be my top function and what would be my bottom function? Let's start with the top function. You're most certainly welcome. Everyone's welcome on this live. So what would my top function be? Not quite. Is my top function x squared plus 3x minus 6? Or is my top function the square root of x? Which one would be on top? Thank you, Earthfan, for the follow. And I apologize if I pronounced that incorrectly. Thank you, Jason, for the follow. Square root, okay. So here, my top function is the function that's on top of the fraction bar. Hence why I call it the top function. So my top function is going to be my x squared plus 3x minus 6. So let me write that down. And then, if that's my top function, what's my bottom function? Right, it's the square root of x. That is absolutely right. So now, I need to take what's scrolling in this live popped up. I got my first calc exam tomorrow. Okay. What's the topic on your calc exam? isn't. Okay. Best of luck, Amir. I know you're going to do well. So, now, step two is to take the derivative of both functions. Thank you, Jamie, and thank you, Bill, for the follow. So now, let's go ahead and take the derivative of x squared plus 3x minus 6. So, using the power rule, what would the derivative of my top function be? Thank you, user, for the follow. Never says 2x plus 3. Right. So, let's use power rule. So, the derivative of x squared, so remember, take my exponent, move it out front, and since there's no coefficient here, you can just say 2x, and then 2 minus 1 is 1. So remember, I can rewrite that as 2x. Why? Because a variable without an exponent is the same as that variable raised to the first. And then, speaking of that, if I have plus 3x, remember, I can rewrite that as 3x to the first. 1 times 3 is 3. X to the 1 minus 1, well, 1 minus 1 is 0, and x to the 0 is 1. So we're left with that. And then we have a minus 6. So if we look, if I have a function that's a constant, its derivative is going to be 0. So therefore, the derivative of negative 6 is just simply 0. What math is this? This is calculus. Thank you, Aaliyah, for sharing the live. And now, we need to find the derivative of this thing. But I don't see an exponent. You're taking differential equations right now. Wish me luck. Good luck, Eugene. I actually struggled a lot when I took differential equations. I almost failed it. What does derivative mean? That's a good question. The derivative tells the story of the slope. So it tells us what the slope of a function is at a specific point. Thank you, Amir, for the follow, and thank you, Brian, for the share. Opinion on stats. If you like word problems, I highly recommend you take stats. It is full of word problems. I didn't take AP stats when I was in school, but I did take a stats class eventually a few years later. Right, Miguel. So remember that x to the m over n is equal to the nth root of x to the m. So if I have the square root of x, that's just going to be x to the 1/2. And now I do have an exponent. I have this 1/2. So now, using power rule again, I can take that 1/2, move it out front, and I have x to the 1/2 minus 1, which is negative 1/2. Thank you, Mokhtar, for the follow. So from here, what I'm going to do is I want to get rid of that negative square root. And in order to do that, remember, x to the negative n is just equal to 1 over x to the n. Now be careful, because only the thing being raised to the negative power goes into the denominator. Nothing else. So this 1/2 doesn't go into the denominator, just that x. So this would be 1 over 2 times x to the 1/2. And remember that x to the 1/2 is just the square root of x. Thank you, Planet, for the follow. Thank you, Ash, for the follow. So now that I've taken the derivative of my top and bottom functions, we now can move on to step 3. And what is step 3? Step 3 is to plug in to the quotient rule formula. Thank you, Shadow, for the follow. Thank you, Yay, for the follow. So remember, so here I'm going to link my functions together. Thank you, Moy, for the follow. So now I have f prime of x is equal to low d high. So that's going to be the square root of x times 2x plus 3 minus high d low. So this is going to be 1 over 2 root x times x squared plus 3x minus 6 all over the bottom squared. So this is going to be the square root of x all squared. And then fourth, simplify if possible. Thank you for the follow. Will you back your camera so we can see the full picture? Sure. Although my camera doesn't have a zoom in or out function, so at a certain point I won't be able to to move it back anymore. So now I need to simplify this. So how am I going to simplify it? Well, I could distribute in this, for that, and do the same here. And then I can square a square root. So we can say bye to those. And I'm left with what? 2x times root x. So that would be 2x to the 1 plus 1 half is 3 halves. Plus 3 root x. Minus, so this would be x squared over 2 root x. So that would be x to the 3 halves over 2 plus 3 root x over 2 minus 6, or plus 6. Oh, this should be minus as well. 6 over 2 root x, which this would just simplify to 3 over root x. Thank you, Huma, for the follow. And what am I left with on the bottom? I am left with simply x. Can I go on here? Well, I guess I could simplify a little bit. So I'm going to rearrange this so that way everything's together. So in order to add or subtract fractions, I need a common denominator. So I can put this and this together. I could put this and that together, and I'd be left with 3 over root x. So here, common denominator between 2x to the 3 halves and negative x to the 3 halves over 2, well, that would just be 2. So this would be 4x to the 3 halves minus x to the 3 halves over 2. And I can do the same here and here. So that would be plus 3 root x, or actually, I need to have a common denominator there, so that would be 6 root x, excuse me, minus 3 root x over 2, plus 3 over root x, all over x. Thank you, Dee Dee, for the follow. And finally, simplifying like terms, I have 4x to the 3 halves minus x to the 3 halves, so that's going to be 3x to the 3 halves over 2. And actually, since this and this have the same denominator, I'm going to just go ahead and combine these two fractions together. So 6 root x minus 3 root x is going to be 3 plus 3 root x, excuse me, over 2 plus 3 over root x all over x. Thank you, Dee Dee, and thank you, Xenon, for the follow. Could I factor that further? Could I simplify that further? Sure, I could. I could have a common denominator there and there. So this would be root x, which is x to the 1/2, times, show the beginning of the problem. Okay, as soon as I'm done with this, I will show it. So here, I can multiply the top and bottom of this fraction by root x, and the top and bottom of this fraction by 2. So 3x to the 3 halves times x to the 1/2 is the same as 3x to the 3 halves plus 1/2. So this would be 3x squared plus 3x, right? Because square root of x times square root of x is x. And then if I multiply 3 by 2, that gives me 6 over 2 root x all over x. So now, can I walk through squeeze theorem? So I'm actually going to focus on quotient rule tonight. I think I've already done squeeze theorem in an earlier live. If I have, yeah, I have. So what I'm going to do, all of my lives are going to end up here. And that is actually one of the first ones I'm going to start with. So if you go here and go to this channel, you'll be able to find all my lives, including the squeeze theorem. Fraction over fraction? Indeed it is. So I'm going to divide two fractions. Remember how to divide two fractions? Keep, change, flip. So this is going to be, and actually I can factor out a 3 there, so I'll go ahead and do that. So I have 3 times x squared plus x plus 2 all over 2 root x times 1 over x. I end up with what? I end up with 3. So I like to simplify then multiply, but I'm not going to here. So 3 times x squared plus x plus 2 times 1 is going to be 3 times x squared plus x plus 2 all over 2 times root x times root x. That would be x to the 1/2 plus 1. That's going to be 2x to the 3 halves power. The question is, does it make sense for me to continue from here, or could I just call it done? Personally, I would probably stop here. If you wanted to call that the square root of x all cubed, you could. Or if you wanted to name this x root x, you could. But personally, I'm going to stop there. Yeah, no problem, Alex. I agree. I would call it done here. Do you do any calculus lives? Well, that is actually what I'm doing right now. Do you do any AP calculus stuff? Yep, that's what I'm doing right now. Oh yes, I was just about to get there, Dart. So here's where I began. Thank you, Joe, for the follow. Thank you, Orange, for the follow. So that is where we started. And then this is where we ended. I'm in college calc this semester, so I'm sure you can help me. I can indeed. Are you taking Calc 1 or 2, Orange? 1? Okay. Yeah, I can definitely help you. I can help you with both. I just like to know. Yeah, so I offer, so if you want, I do online math tutoring, so if you want, feel free to DM me and we can set up a consultation to get you going on that. Awesome. Yeah, go ahead and send me a DM info and we'll set up a consultation. Cool. Thank you, Tyler, for the follow. So, awesome. So now, let's say we do 1 or 2 more, and then we will call it a day. Because, how does the square root under the fraction thing work? Insane, I'm literally doing this in school right now, and I've come... Yeah, perfect timing, Andrew. How much does my tutoring cost? So, normally I like to charge based on how often you want tutoring and how long you want tutoring each week. So someone who wants tutoring 1 day a week is going to get charged more than someone who wants 3 days a week. Or the price per hour goes up if you do less. Do you do Chem 2? I haven't done chemistry since 2010. I was a junior in high school back then, and my teacher had short-term memory loss, so that was quite the experience. But no, I don't do chemistry. Um, I wish I knew someone on here. I wish I knew someone on TikTok that did chemistry. Is chemistry the same as math? Nope. It has math in it, but it's not the same as math. Thank you, Seven, for the follow. Thank you, Ulysses, for the follow. Can you help explain completing a square? I'm pretty confused. What if your schedule only allows... Yeah, that works. That is perfectly fine. There's no... So I have no minimum... time per week. If we want... Like I said, if we wanted to meet like once or twice a week, that works for me. Couldn't you rewrite the denominator as x and 1/2, then bring it to the numerator and then product rule? You could. But tonight the goal is to show quotient rule. So that's why I'm choosing to do it that way. But yes, you could do that. You could make this x and negative 1/2 and then distribute and then take the derivative there. Thank you, Peace, for the follow. Cool. All right, let's do 1 or 2 more, and then we'll call it a night. So we'll be able to do more of these as well as we learn more and more types of derivatives. Like we could plug in all the 6 trig functions in here. We could plug in e and ln. But since we don't have those on the list yet, I want to go over those derivatives first. Thank you. I think that's a heart for the follow. Yeah, for some reason, if you have an emoji as your username, it's kind of hard for me to see what exactly the emoji is. So if it's not that, I apologize. So yeah, f of x is equal. What should we make it equal to? What should we do? Let's do, this time, squared on top, x minus x, all over let's do that this time. So, remember the 4 steps. Step 1 is to identify the top and the bottom function. So my top function, I'm going to call t of x, and t prime. And then bottom is what I'm going to call b of x, and therefore the derivative would be b prime of x. So, I did write this square root kind of comically large, but that's because I wanted to plug in something else in here, but I realized we don't know how to do something like that yet. But we will soon. So I'm going to let the top function be the square root of x minus x. And the bottom function is going to be 3x squared plus 7. So now I've identified my top and bottom function. So step 2 is to take the derivative of both functions. So what would be let's start with the derivative of the bottom function. What would the derivative of 3x squared plus 7 be? John says 6x. Art says 9x. Sauce says 6x. It looks like we have some contention as to whether it's 6x or 9x. Nope, we don't need the constant of integration here, Mignail. Yeah, so it would be 6x. Why? Because this is a 2. Thank you, Hollow, for the follow. So 2 times 3 gives me 6. X to the 2 minus 1. So 2 minus 1 is 1. And then the derivative of 7 would be 0. Sorry. Yes, that's right, D. If I were taking the integral, that would be exactly right. Thank you, Jesus, for the follow. And now, let's go ahead and plug and find the derivative of the top function. Thank you, Afago, for sharing the live. So, here is the top function 1/2 x and a negative 1/2. Almost. Thank you, Leo, for the follow. Thank you, Shorty Mac, for the follow. Thank you, Vindir, for the follow. So here, what I'm going to do is I'm going to first take the derivative of the square root of x. Thank you, VT, for the follow. Right, it would be 1. So the derivative of root x, remember, root x is equal to x to the 1/2. So the derivative of x to the 1/2 is 1/2 x to the negative 1/2. So this would be 1/2 x to the negative 1/2, which I can rewrite as 1 over 2 times the square root of x. Right? Because when I have a negative exponent, I just move it down to the denominator. Thank you, Hammock, for the follow. And then the square root of negative x is just negative 1. So now, from here, we are ready for step 3. And what is step 3? Step 3 says to plug into the quotient rule formula. So what is the quotient rule formula? Well, it's low d high minus high d low all over the square of what's below. So here, f prime of x, beautiful way to head to bed, not gonna lie. And hey, if math helps you fall asleep, then so be it. So here, low, d high. So these two functions are gonna go together. So I have 3x squared plus 7 times 1 over 2 times root x minus 1 minus the derivative of top minus times the bottom. So this is going to be 6x times the square root of x minus x. And that's going to be all over the bottom squared. So this is going to be 3x squared plus 7 all squared. So from here, now, my final step is to simplify if possible. So, let's see what happens here. You're doing great, but this reminded me of why I dislike calculus. It was so complicated for me. You're doing great at teaching Bible. Yeah, no problem. No offense taken. I do the best that I can. But anyway, so now let's see what happens. So I have 3x squared times 1 over 2 root x. So that's going to be 3x squared. 3x squared over 2 root x minus 3x squared times negative 1 is 3x squared. Inside is going to give me plus 7 over 2 root x. And then 7 minus 1, or positive 7 times negative 1. Wait, shouldn't you cancel one of the 3x squared plus 7 first? Nope, because I'm subtracting these two things together, so I can't just cancel that 3x squared plus 7. If I were multiplying by the 6x times root of x minus x, then yes, absolutely I could do that, and I would do that. And then this is going to be minus 6x root x plus 6x squared all over, what would that be? That would be 9x to the 4th. 2 times 3 times 7 gives me 42. X squared plus 49. So now from here at this point, it's just time to clean up a little bit. So, I can combine these two, and I can combine these two. But is that what I should do? Or should I factor out a 3x squared minus 7? Let's see how this goes. Let's see how this goes. Hey, Math Tutor, how's it going? So I have 3x squared plus 7 over 2 root x minus 3x squared minus 7. Ooh, this might clean up quite nicely. What grade math level is this? This is Calculus 1. Thank you, Andy, for sharing the live. Things are going well? Fantastic. So this is going to be 6x times root x, so that's going to be x times x to the 1/2, so that's going to be x to 3/2. This might actually... This actually might simplify pretty... This might actually... Yeah, I hope... Let's see if it simplifies. 42x squared plus 49. What if instead of doing that, I just simplify that by making this x squared minus x minus 1/2, so that would be 3 over 2 x to the 3/2 plus 7 over 2 x. Oh, yeah. Yeah. 7 over 2x, so negative 1/2. 3x squared, negative 3x squared plus 6x squared gives me plus 3x squared. Minus 6x to 3/2. Yep. All right. This is going to simplify nicer than I thought it would. X squared plus 49. 3 over 2x to 3/2 minus 6x to 3/2. So that's the same as, this is what? This is 3/2 minus 12/2. So that would be... And actually, I'm going to write this in order, in descending order of powers. So this is going to be 3x squared. So negative 12 over 2 minus the plus 3 over 2 is going to be minus 9 over 2 x to 3/2 plus 7 over 2 root x all over 9x to the 4th plus 42x squared plus 49. I think I can't simplify any further, so that I'm going to stop here. Yeah, I'm going to stop here. So there's a saying that the hardest part of calculus isn't the calculus itself, it's the algebra. And that's why when we do these, when we do calculus, it's really important for us to understand the algebra. Because, like that, going from here to here, okay. What calc is this? This is Calc 1. Good question, Frozone. Alright, Hart, what is your question? Alright, can you do graphing for Algebra 2? Thank you, M, for the follow. Can you do graphing for Algebra 2? There's a lot of graphing in Algebra 2. Is there anything in particular that you want me to go over with graphing? I'm taking this. I barely practiced yet. Okay. Related rates were awful in Calc 1. I think related rates are among one of the hardest parts of Calculus 1. Why? Because it forces us to interpret word problems into from words to problem. Do you factor at any point in this equation? Simplify, yes. Factor, I mean, I theoretically could, but how did how did 3x squared become positive? Negative 3x squared plus 6x squared becomes becomes positive 3x squared. Dog, I'm over here struggling on Algebra 1. That's okay. We all have to start somewhere, Emilio. We all definitely start somewhere. Where did the negative 7 go? You're right. You're absolutely right. I forgot that 7. Sorry about that. You're right. I'll be honest with you. It's not this isn't the first time I've made a mistake, and I don't even think it's the first time I've made a mistake tonight. But it's definitely not the last time I'm going to make a mistake. Can't you factor in x to the negative 1/2 from the numerator? You could. Um, but with this negative 7, I wouldn't. In fact, with that negative 7, there's no x to negative 1/2 power. Can you do another example? Yes, I can. In fact, this is now time for the final problem. Yeah, no problem. I'll be honest with you, Kai. I forgot to put it there. So, it's my fault. Will you go live tomorrow? Yes, I will. I will be going live at about 11:30 p.m. Eastern. Thank you, Kai, for the follow. All right. So, it is time for the final problem. What is this? This is Calculus 1. Thank you, Jorge, for the follow. See you tomorrow as well. Thank you for the help. I'll try to follow along on Notebook as well. Okay. Yeah, have a good night. And like I said, all of my lives are going to end up here. So if you leave and need to catch up, this is where you'll find them. I'm like a week behind, but my goal is to try to get them all on here by Friday, which I think I can do. All right, so to get to the final problem tonight, there are 53 of us in here. Let's see if we can't hit 7.5K likes before the final problem. Thank you, Frozone Dad, for the follow. Let's do a quick mad tap to 7.5K. I know you all can do it. Gives me a chance to drink some water, too. Yeah, when I first started going live, I underestimated the importance of keeping some water or something to drink nearby because I don't know about you, but when you talk for a long time, your throat gets kind of dry and you start coughing a lot. So it gets to the point where it's like, okay, I need to not cough as much, so I'm gonna drink some water. Does Calc BC cover cylindrical shell method? Yep. Yes, it does. So Calc AB covers that as well. So Calc BC covers everything Calc AB does, plus a few other topics at the end. Thank you, Ken, for the follow. But yeah, so right like sequences and series and polar. Yep, exactly. Do you do Calc 2? I do. Um, with lives, I'm probably gonna get into the Calc 2 curriculum. I'm thinking, and like I said, I don't have my exact schedule in front of me, so I can't be know for sure. But I think I'm gonna get to Calc 2 probably around, if I had to guess, end of September, beginning of October. But again, it could be sooner, it could be longer, but that's where I'm guessing I'll be. Thank you, Violet, for sharing the live. All right, we're almost there. Maybe I should have made it 10K. Nah, I said 7.5. And did I ever partake in competition math? So I did. If you want to count math team when I was in high school, then yes. Like AMC, nope, I have never done AMC. Oh, I think it would be kind of cool to it might be cool to like train people, like train students to do AMC. Hmm. Thank you, Math Tutor, for the heart me, and thank you, Ken, for the rose. AMC is fun. Yeah, I'll have to look into it. Awesome. So, let's go ahead and move on to the final problem since you already got to the light goal. I knew you all could do it. So, what shall I put as the final problem? All right, let's do this. So, let's do 4x cubed plus 7x squared minus 6x all over 3x minus 2. So for this problem, I'm going to have you walk me through it. So step 1, we look through our steps, is to identify the top and the bottom function. So I'm going to start with that. What type of equation is this? This is a rational equation. This is a rational function. So my first step is to identify the top function and the bottom function. On top, I have a cubic function, and on the bottom, I have a linear function. All right. Let's see if you're right, John. So my top function is going to be this cubic right there. So I have 4x cubed plus 7x squared minus 6x. And on the bottom is my linear function, 3x minus 2. So now we've identified the top and the bottom function. My second step is to take the derivative of both functions. So, what is the derivative of 4x cubed plus 7x squared minus 6x? What do we think? Thank you, John. Yeah, so the derivative of this is the following. So I'm going to use power rule for all three of these terms. So I have 3. So power rule says take my exponent, move it out front, and subtract 1 from the exponent. So I have 3. Moving it out front, I have 4 times 3 is going to be 12. X to the 3 minus 1, which is 2. And then here, I do the same thing. So I have 2 times 7 is 14. X to the 2 minus 1 is 1. And then, remember, a variable without an exponent is the same as 6, x is the same as that variable raised to the first. So I have 1 times negative 6 is negative 6. X to the 1 minus 1 is 0. So remember, x to the 0 is just 1. So that is the derivative of the top function. How you get a derivative? So the derivative tells the story of the slope. So it tells us what the function, what the slope of a function is at any given point. So all we do is we're just using power rule. And what does power rule say? Exactly. So it's if I have some variable raised to the nth power, what I do is I take that n, move it out front, multiply it by any number that's in front of the x, and subtract 1 on top. It's almost as if I'm taking a copy of n, moving it here, and then I now have n minus 1 copies on the top. Over what power? I just cut my nails a few days ago. Anyway, so from here, now I need to take the derivative of 3x minus 2. What is the derivative of 3x minus 2? Right, George, it's 3. Why? Because, remember, a variable without the exponent is the same as that variable raised to the first. So I have 3 times 1 is 3. X to the 1 minus 1, 1 minus 1 is 0. And x to the 0 is 1. Thank you, Pink Panther, for the follow. And then the derivative of negative 2. Well, negative 2 is a constant, and the derivative of any constant is 0. So this is the same as 3 plus 0, or just 0. Thank you, Aiden, for the follow. So now, thank you, Andrew, for the follow. So from here, now that I've taken the derivative of both of these functions, it's time to plug it into our quotient rule formula. And actually, what I meant to do, and I should probably do it now, is I will go ahead and just quickly write down that function. So that way, we always have it to refer to. Quick question, should I take linear algebra after Calc 1 or wait until after Calc 2 or even 3? I would definitely wait till at least Calc 2. Till you're done Calc 2. So, quotient rule is low d high minus high d low all over the square of what's below. So now I'm going to plug in my formulas here. So I'm going to link these two together, and I'm going to link these two together. Is a constant just any whole number? Yes. Yes, it is. This is algebra. This is calculus, but yes. There are certain concepts I would need in Calc 2 for it because some people... So, Calc 2 gives you a good foundation for... Calc 1 and Calc 2 gives you a good foundation for any math that you need to do in the future. Yeah, I agree. Taking 2 does help with 3. Oh, do you have a math degree? I do. Can I try a millennium problem? Good one, Coda. I'm not that good at math. I it would take me it would take me a millennium probably just to make some progress on it. So after this problem I'll explain what Coda is referring to. Have I ever done IB math? Personally, no, but I have tutored kids with in IB maths. In fact, I actually am tutoring 3 of them in IB math right now. Thank you, Joni, for the follow. So, let's go ahead and plug that in. But can you prove the quotient rule? Yep, I did at the beginning of this live. And again, you'll be able to see that when I post my live here. But yes, I did prove the quotient rule earlier. So, now let's plug this in. So f prime of x is equal to b of x times t prime of x. So that's going to be this times this. So I have 3x minus 2 times 12x squared. I feel like I'm yelling into this. I apologize if I am. I need to adjust the sensitivity of the mic. Or I just need to speak quieter. One of it two. Thank you, Globe, for the follow, and thank you, Carlos, for the follow. Minus t of x times b prime of x. So t of x times b of x. So, or b prime of x. So that would be 3 times 4x cubed plus 7x squared minus 6x. And again, I'm going to go ahead and raise that up a little bit so that way we can see all over the bottom squared. 3x minus 2 all squared. Should I take a dual credit pre-calculus as a junior in high school? I want to be a civil engineer. If you're talking about dual enrollment, I'll tell you what, it doesn't hurt. It does not hurt. So from here, now my last step is to simplify if possible. And the reason why I put if possible is because sometimes we won't be able to simplify. But here, I'm going to go ahead and do so. So I'm going to FOIL these two terms, or this binomial into that trinomial, and then I'm going to distribute that -3 here, here, and here. And that's the other thing. Take it if the university or college you plan on going to is going to accept the credit. Absolutely. And that's the thing. A lot of the state schools have contracts with or most of the community colleges are part of the larger in-state, but it's not for all states. But yeah, just make sure that the college that you do want to go to is the make sure that the college you go to does accept it if you're going to do dual enrollment. Can you zoom out? So yeah, so here is probably the furthest I'm going to be able to zoom out. Why you squared the bottom? Because it's part of our quotient rule. I wish I could take a calc class. It's not in my degree. Go. All you can do is stream. You might be able to take it as an elective. Yeah, you might be able to take calculus as an elective. So don't give up yet, Aiden, on taking calc. So now I'm going to try and simplify that. So this is going to be 3x times 12x squared. Actually, I'll do the FOIL up here. So 3x minus 2 times 12x squared plus 14x minus 6. So here I get 36x cubed. 3 times 14, what does that give me? Or that would give me 42x squared. And then here, 3x times negative 6 gives me negative 18x. If I do the same on the bottom, I get negative 2 times 12x gives me negative 24x squared. Negative 2 times 14 gives me negative, not positive, 28x. And negative 2 times negative 6 gives me a plus 12. From here, thank you, May, for the follow. So from here, I just add these two together. 36x cubed gives me 36x cubed. 42x squared minus 24x squared, that's going to give me what? 18x squared? Negative 18x minus 28x is minus 46x plus 12. Yeah, let's watch the language mode, but I'm not really sure, can you help me with calc? Yeah, I can help you with calc. Yeah, so like I said, I do offer online tutoring, so yeah, feel free to send me a DM and we can set up a consultation. No problem. Like I said, sometimes that language, comes out too. So I definitely understand. But let's try and watch our language. So here, I'm just gonna plug that into fractions. So I have 36x cubed plus 18x squared minus 46x plus 12. And I'm getting it from up here. So then, now I'm going to distribute in that negative 3 into these three terms. So that's going to be negative 3 times 4 is going to be negative 12 x cubed. Negative 3 times 7x squared is going to be negative 21x squared. And negative 3 times 6x is going to be plus 18x all over. I'm going to leave that. Are you working on quotient rule tonight? I am. How's it going, Hefe? Always study with the person who does their math in pen. The rest of us need to erase too much. Yeah, no, I normally don't do math in pen, but the pencils that I have don't really show up on this paper too well. So that's why I use a pen. But as you can see, I still make mistakes. Oh, I do remember you asking that. I wasn't trying to ignore you. I do apologize. Can you do dot product and cross product by any chance? So tonight I'm just focusing on the quotient rule, but I can add it to my list. So dot cross products. So yeah, I'll add those to my list. So I'm going to wait to square that. So in the numerator, let me zoom in a little bit so that way we're focused on the step that we're working on. That might have been a little too much zooming in. There we go. Maybe a little bit less. Perfect. Okay, so in my numerator, what would I be left with after I reduce or simplify? Thank you, Stein, for the follow, and thank you, Kimmy, for sharing the live. So just focusing on the numerator for a moment, what can I simplify that? What can I simplify to? Right, I can combine like terms. So after combining like terms, what would I be left with? I guess is a better question. Have you gone over indeterminate for limits by chance? My professor zoomed over them in 15 minutes. I don't remember. That's hard to type on phone. Okay, here's what we'll do then. X cubed, x squared, x, and constant. I'm going to give you the constant as 12. Type in the following numbers in order. Or type in your answers in order. So x, the coefficient next to x cubed, the coefficient next to x squared, and the coefficient that goes with x. Sorry, I didn't mean to, I don't mean, you're not bothering me. No problem. No problem. Ask as many questions as you want. When you add it to the list, does that mean another live? Yes. Yes, it does. It means it's going to be on my list of future lives to do. Almost, Ethan. Yeah, no problem. No problem at all. Right. So 36x cubed minus a 12x cubed. Yes. Yes, Dillbot, it would be 24x cubed. Yep. And then 18x squared minus a 21x squared is going to be a negative 3x squared. And then negative 46x plus an 18x, that's going to give me what? Plus 28x? That's okay. That is perfectly fine. I tell my students all the time, if you need to work it out on pen and paper, go for it. I don't even do a lot of I even don't do a lot of these problems on from memory. Thank you, Isa. I'm really sorry for pronouncing your name incorrectly. Izij for the follow. Thank you, Dilbot, for the follow. Wow, I might have to do math on my free time. Learn more of this is fun. I'm glad you're having fun, Alex. I'm really happy that you're having fun. Yes, math is not meant to be something that's torture. It's wish. Thank you, Dilbot. I really appreciate that. Thank you, ZX, for the follow, and thank you, Monasty, for the follow. Yes, so it would be 3x times 3x is 3x is 9x squared. 2 times 3 times 2 is going to be negative 12x. And then negative 2 plus 2 is 4. Thank you, Kimmy, for the follow. Never mind. Did I miss your comment? I apologize, George, if I did. When I did the first foil, I got something like... It's possible I did my math wrong. So 3 times 12x squared is 3x. That's right. 3x times... That's right. And that's right. 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 Thank you, BO, and thank you, G1, for the follows. We get the bottom answer due to foil. Right. Thank you, Flacco, for sharing the live, and thank you, Alexander, for the follow. You're reviewing Laplace transform right now? Okay, that's awesome. In general, though, we wouldn't expand the denominator, right, so you could find critical points. Right. Right. Um, the question now is, can I simplify this any further? And the answer is, I'm not going to try. Let me make that look more like an 8. There we go. I'm going to stop right here. Cool. And that is quotient rule. You're right, it should be negative. You're right. You are absolutely right, Apple user. I have to watch my signs. Yeah, like I said, I even as you can see, I make mistakes. I have Calc 3, 8 a.m. tomorrow, third quiz of Crow. Good luck, Mo Nasty. I hope you. I know you're gonna do well. So, with that, I'm gonna go ahead and call it a night. But before I go, I want to share with you a couple of things. So, is this Calc 1? Yep, this is Calc 1. So, all of my lives from I think a couple weeks ago on are gonna and I'm gonna download them and post them here. And here is my here's my channel over there. Thank you, BO and Tracy, for the follows. So if you go here and go to this channel, you'll be able to find all of my lives. And then once you get there, if you could do these 5 things, that would be awesome. I have to download a few of my lives, so it's going to take a little while, but thank you, Oops, for the follow. But as soon as I do, they will all be up here. And then there are a couple of other people that I would like to recommend that you follow. So, if you're getting ready for your GED, your ASVAB, your AccuPlacer, your TEAS test, or if you just need a review of Algebra 1 or 2 or Geometry, I highly recommend that you follow ACG Math Tutoring. She's really awesome. She was the one who convinced me to join TikTok here to start with, so if it weren't for her, I wouldn't be here. And then, learning with Lynette. So if you're interested in learning about the abacus, which I think is really cool, I honestly didn't think I was gonna when I joined TikTok that I was gonna learn a lot about the abacus or be interested in it. But I can tell you this: learning with Lynette is really awesome when it comes to learning about the abacus. And actually, I think she's live right now. So as soon as we're done here, I'm gonna be jumping into her live, and then I also offer online math tutoring in all of these subjects. So, I offer group tutoring and I also offer one-on-one tutoring. So, for group tutoring, I offer group tutoring to groups of 3 to 10 students, all taking the same class, not necessarily with the same teacher or at the same school, but just taking the same class at the same time. For example, if you and 4 of your friends are all taking Calculus 3, then you could all sign up for online tutoring, and for that, I charge $35 per hour. And then I also offer one-on-one tutoring, and with that, I offer one-on-one tutoring. So if you're interested in either one-on-one or group tutoring, feel free to DM me, and we will set up a free consultation. Do you ever do private tutoring? Indeed, I do. Yeah, Mo. If you want, just feel free to send me a DM, and we can set up a consultation. How much is it? It really depends on the amount of times you want tutoring per week. Um, so the more often you um the more often per week that you have tutoring, the less it'll cost per hour. But I usually go over that in a consultation too. Cool. So with that, everyone, I hope you all had fun. I know I did. And tomorrow, I think I said I was going over trig limits. Um, so yeah, if you want, Mo, like I said, feel free to DM me, and I'll be happy to answer those questions for you. So yeah, with that, have a great rest. I will be going live at 11:30 p.m. Eastern tomorrow. So with that, have a great rest of your evening, everyone, and I will see you all again tomorrow at 11:30, or should I say today, because over here on the East Coast, it is 1:45 in the morning. So yeah, have a great night, everyone. Bye now. Wait, real quick, do you do Calc 3? Yep, I do. I do indeed do Calc 3, Rack. No problem. Thank you for the follow. Alright, everyone, have a great rest of your evening. Bye now. Oh, interesting. Go live for 4 more minutes and you'll. Okay. I guess I'll be live for the next 5 minutes. What about XY interlopers? Interslopes. One more problem. I don't have another problem prepared, unfortunately. Plus, like I said, it's getting late. So let me look up what that is that you're talking about. XY interslopes. Are you talking about intercepts? Thank you, Poppy, for the follow. But yeah, Ellie, are you talking about intercepts like let's say this? You're learning this in algebra in my brain. I okay. Are you talking about that, Ellie? Because I've never heard of interslopes before. I'm afraid. Thank you for the follow, Epsilon. Ooh, 14K likes. Let's go. But yeah, I don't actually remember the last time we had 14K likes on a live. That's actually really cool. Thank you, everyone. And like I said when we got to 1,000 followers, I appreciate you all for sharing the live, for liking the live, for commenting on the live, for following me, and for being in here in the first place. Because let's be honest, there's not a single person here on TikTok who doesn't go live and um and wants to be live in front of nobody. But I did. I realized that I wouldn't be at the place where I am right now with in this on this platform without you all. So again, thank you all for that. So yeah, Alright, so now... Yeah, I think that's what she... I think so too. But yeah, so... Alright. Have a great evening, everyone. Or, like I said, for me, it's morning because it's almost 2 in the morning over here on the East Coast. And I will see you again at 11:30 p.m. on tomorrow. Bye, everyone.